Howdy students, this is going to be the second part of the All Shook Up answer keys. This is going to be questions 6 through 10. So let's go ahead and get started. Number 6, what volume in liters would 3.75 times 10 to the 35th atoms of helium occupy at STP? So what we're going to do is start with what is given in the problem, 3.75 times 10 to the 35th atoms, specifically of helium. So we're going atoms to liters. This is going to be a two-step problem. We're going to use Avogadro's number because we have a particle times 10 to the 23rd atoms of helium, and that's going to equal 1 mole of helium. And then one more step to go from moles. 1 mole of helium is 22.4 liters of helium. And again, at STP. If it's not at STP, 22.4 is no good to us. When we calculate, we get a final answer of 1.40 times 10 to the 13th, and that's going to be liters of helium. Problem 7. How many hydrogen atoms are there in 12 grams of glucose, C6H12O6? So we're going to go ahead and start what we're given in the problem, and that's going to be 12.0 grams of C6H12O6. We're looking for hydrogen atoms specifically. So this is going to be a mole-to-mole ratio problem. We're going to have to add one additional step. So first things first, I need the molar mass of glucose, and I'm going to go ahead and give it to you. If we were to calculate it, we would get 180.0 grams of C6H12O6. And that's going to be equivalent to 1 mole of C6H12O6. From here, we can do a mole-to-mole ratio, and we can say that for every 1 mole of C6H12O6, I have 12 moles of hydrogen atoms, because there are 12 equivalents of hydrogen inside that compound. From here, I can use Avogadro's number. I can say that 1 mole of hydrogen is going to be 6.02 times 10 to the 23rd atoms, specifically, of hydrogen. And when I calculate, I'm going to get 4.82 times 10 to the 23rd, and that is atoms of hydrogen. Okay, number 8. What is the mass of 19.6 liters of CO2 at STP? So I'm going to start with 19.6 liters of CO2, carbon dioxide, at STP, the standard temperature and pressure. 0 degrees Celsius, 1 atmosphere. 22.4 liters of CO2 on bottom, 1 mole of CO2 on top. Now I'm going to convert moles into grams using the molar mass of CO2. For every 1 mole of CO2, the molar mass, I'm going to give it to you, is 44.0 grams of CO2. When I calculate, final answer is going to be 38.5 grams of CO2. Okay, I had to erase because my pen was not going to let me continue. So here is 9 and 10. If you need to go back, go ahead and pause the video or rewind in order to get back to the first couple of problems. Here's number 9. Calculate the percent composition of calcium carbonate, CaCO3. Calcium carbonate is also called limestone. It's found in coral and sidewalk chalk as well. So let's calculate the percent composition. The first thing I'm going to need to do is go ahead and calculate the molar mass for this compound. So I like to list out my elements: calcium, carbon, oxygen. Calcium, we have 1 of those. Carbon, we have 1 of those. And we have 3 oxygens. The molar mass of calcium is 40 40.1. The molar mass of carbon is 12.0. Oxygen, 16.0. When we multiply those out, we get 40.1, 12.0, and 3 times 16 gives us 48.0. When we add these up, our molar mass is 100.1, and that's grams per mole of CaCO3. In order to find the percent composition, we're going to take our total, and we're going to take each part and divide it by that total. So 40.1 divided by 100.1, 12.0 divided by 100.1, and 48.0 divided by 100.1. And then we multiply each one by 100 to get ourselves a percentage that's out of 100 rather than 1. And our final answers here are going to be 40.1% calcium, 12.0% carbon, and 48.0% oxygen. And you'll notice, because we're dividing by 100 and then multiplying by 100, the percentages are going to look like the parts that we are dividing them by. This doesn't always happen, but in this case, it is. So here are our answers, and of course I would report those in this box over here. Number 10, how many grams are in 3.98 liters of neon gas at STP? And again, we see STP because we're dealing with gases. I'm going to work it out down here. 3.98 liters of neon. First step would be to convert 22.4 liters of neon gas is equivalent to 1 mole of neon gas. Now I'm looking for grams, so 1 mole of neon. I look on the periodic table in order to get grams, and that would be 20.2 grams of neon gas. And we'll go ahead and calculate. Final answer that I'm going to get here is going to be 3.59 grams of neon gas. Okay, and then go on to part 3 to see the last few questions.